Okay, we're going to look at operations on complex numbers. First, we're going to start by looking at what a complex number is. And I guess before we look at what a complex number is, we look at the imaginary number. So we know that we can't take the square root of a negative and get a real number, but we can take the square root of a negative and get an imaginary number. So the square root of -1 is defined as the imaginary number, and it's denoted by I. A complex number has a real part and an imaginary part. So this would be a complex number. And we'll note also that if you take the imaginary number and square it, what you get is -1. So I squared is equal to -1. So we're going to look at operations on complex numbers. So we're going to look at 7 plus 2i plus 1 minus 4i. Okay, I'm going to get the real parts together, so 7 plus 1, and I'm going to get the imaginary parts together, 2i minus 4i. So it's like terms, so the 7 plus 1 is 8, and 2 minus 4 is -2. So we get 8 minus 2i. -2 plus 6i plus 4 minus I. So I get the real parts together and the imaginary parts together. So that gives me 2, and that gives me 5 minus 1, or 6 minus 1 is 5. So 2 plus 5i. Let's look at when we subtract complex numbers. Okay, so we take the real parts, and we're going to take 3 minus 5. We look at the complex part or the imaginary part, and we have 2i minus a minus. Okay, so 3 minus 5 is -2, and here we have 2 plus 7. So we get -2 plus 9i. When we multiply, so if I have -3i times 7i minus 5, then what I do is I distribute just like when I have polynomials. And so -3 times 7 is -21. And then I times I is I squared. And then I have -3i times -5, so that's going to become plus 15i. Now I squared, we saw on the first slide, is equal to -1. And so a minus and a minus is a plus. So this becomes 21 plus 15i. And that's my answer. That got messy. Okay, let's look at another one. -5 plus 4i times 3 plus I, and we distribute. So -5 times 3 is -15, minus 5i plus 12i plus 4i squared. Okay, so minus 15. This is equal to minus 1. So minus 15 minus 4. And then minus 5 plus 12 is 7i. So see, both of these have I terms in them, so we combine the coefficients. So minus 19 plus 7i is the result there. So you have 8 minus 4i times 2 plus 3i. Well, let's make that a minus. 2 minus 3i. So 2 times 8 is 16. 8 times minus 3 is minus 24. I. Minus 8i. And then minus a minus is plus. So we have 12. I times I is I squared. That's going to give me minus 32i. And here, that's going to give me minus 1. So I get minus 12, because plus and minus is minus. And then combine that, and I get 4 minus 32i. Okay, now we're going to look at 3 plus 5i, 3 minus 5i. So I get 3 times 3 is 9. 3 times minus 5 is minus 15, and then I have the I, plus 15i, minus 25i squared. Alright, so plus 15 and minus 15, those are going to cancel. So I get 9 minus 25, and then I squared is equal to minus 1, so this becomes 9 plus 25 is 34. Okay, let's look at another one there. Um, 2 plus 7i times 2 minus 7i. So 2 times 2 is 4, minus 14i, plus 14i, minus 49i squared. So again, plus 14i minus 14i cancels. I get 4 minus 49, and then remember that that's minus 1. So I get 44 plus 49 equals 53. Now, we might start to notice a little pattern here. So what happens is we get the first two numbers multiplied together. So that's 2 times 2 is 4. And then we end up with the last two numbers squared, and it's positive. So this is in a special form. So the form that we've been looking at is a plus bi times a minus bi. So these are called complex conjugates. So the real part has the same sign, but the imaginary part has opposite signs. So let's look at one more. Oh, well, and we can see that when I expand this, a times a is a squared plus abi minus abi minus b squared times I squared. So those cancel, and I get a squared minus b squared times minus 1. So I end up with a squared plus b squared. So if I have the complex conjugate, a plus bi times a minus bi, the result is a squared plus b squared. So let's look at another example. 4 plus 3i times 4 minus 3i. So I'm going to get 16. And then 3 times 3 is 9. And it's going to be plus. So that is 25. So that's the product of those two. Now, the reason we look at complex conjugates is because when we're dividing complex numbers, that's how we do it. So here we have 5i divided by 2 minus i. So what I do is I multiply on top and bottom with the complex conjugate of the denominator. And so remember, when I multiply fractions, I multiply across the top and multiply across the bottom. So here I get the complex conjugate. I get a complex number times its conjugate. So I'm going to get 4 plus 1. And then on top, I multiply as normal. So 5i times 2 plus I. So that's 10i plus 5i squared over 5. So 10i plus minus 5, all over 5. So I'm going to rewrite that as minus 5 plus 10i over 5 equals minus 1 plus 2i. And my math lab will want you to reduce that. Let's look at another one. 2 plus 3i divided by 4 plus 5i. So I start by multiplying top and bottom by the complex conjugate. On the bottom, this becomes 16 plus 25. And on the top, I multiply as I did earlier. So 2 times 4 is 8. And then minus 10i plus 12i. And then here we get minus 15i squared. So it's going to become plus 15. 8 and 15 is 23. And then plus 2i over 16 plus 25, 41. And then I'm going to enter it into the computer. 23 over 41 plus 2i over 41. All right. Maybe one more. Okay, so I'll multiply on top and bottom by complex conjugate. The bottom, it becomes 16 plus 9. And then here, I'm going to distribute. So 12 minus 9i minus 16i. And then minus 4 times minus 3 is plus 12i squared. So it becomes minus 12. And so that cancels. And I get minus 9 minus 16 is minus 25i divided by 25. So the result is minus I.